All right, everyone, welcome back. Today we're doing another video on molarity. Today we're going to discuss using mass with the molarity equation, either using a given mass to determine the concentration of a solution with a defined volume, or using a concentration and volume of solution to determine the mass that would be required to make that solution. So let's go ahead and get started here. Look at this problem. What mass of solid sodium hydroxide is required to make a 500 milliliter sodium hydroxide solution with a concentration of 0.200 molar? Now I'm going to go ahead and convert this 500 milliliters to liters, 0.500 liters, of course, because the molarity equation is molarity is equal to moles per liter, not milliliters. So we need to make sure that we're using liters when we do this. Now I'm going to rearrange this equation to solve for moles, because I know that I can get from moles to grams to mass. Molarity times liters is equal to moles. After doing that, I can plug in my molarity and my liters because those are both given in the problem. So my molarity here is 0.200 molar. I'm going to multiply that by my 0.500 liters, and I will get how many moles of sodium hydroxide would be required, and that is 0.100 moles of sodium hydroxide, our solute. Now I'm not done because the problem says what mass. So I need to go ahead and convert that 0.100 moles of NaOH, sodium hydroxide, to grams. 1 mole of sodium hydroxide has a molar mass of 40.00 grams. And we can see we're going to cancel out our moles of sodium hydroxide, left with grams of sodium hydroxide. So we get our answer here to be 4.00 grams of sodium hydroxide would be required to create this solution. Now there's an alternate way to show your work for this problem. I kind of prefer the second way again, but either way will work. Either way will get you the correct answer. Let's take a look at the second method here. We have 0.500 liters of solution. That's an amount. We can go ahead and we can use the concentration of the solution as a conversion factor to get to moles. So in our solution, which is 0.200 molar, that means for every 1 liter, we have 0.2 moles of sodium hydroxide. Now, if you look here, what you'll notice is that the liters of solution cancel. And right now I'm left with moles of sodium hydroxide. If I have moles of sodium hydroxide, I can just go ahead and use the molar mass to convert. 1 mole of sodium hydroxide, again, equals 40.00 grams of my solute, sodium hydroxide. And if I do this, 0.5 times 0.2 times 40, I get, again, 4.00 grams sodium hydroxide. I find the second method a little bit neater, but either one gets you the correct answer. All right, so what is the concentration of a solution made by dissolving 20 grams of sodium chloride in water and diluting to a total solution volume of 1.50 liters? So let's go ahead and take a look at this problem. We have 20 grams of sodium chloride. We know that the equation for molarity is equal to moles per liter. So in order to use this equation, of course, we need moles of our solute rather than grams. So let's convert 20.0 grams of sodium chloride to moles. 1 mole of our sodium chloride is equal to 58.44 grams of sodium chloride. So how many moles do we have? We have 0.342 moles of our solute, sodium chloride. Now we can go ahead and plug this in to our molarity equation. Molarity is equal to moles per liter. No need to rearrange because we're looking for the molarity in this case. So molarity is already on its own and in the numerator. So we just plug in 0.342 moles of sodium chloride. We're going to divide that by our total volume, 1.50 liters. and we'll get our concentration 0.228 molar sodium chloride solution. Of course, there is an alternate method to solving this problem, treating the entire thing as a dimensional analysis. We're starting with 20 grams. That's an amount of sodium chloride. So if we have 20.0 grams of sodium chloride, we can of course convert that to moles the same as we did before by dividing by the molar mass. 58.44 grams sodium chloride is equal to 1 mole sodium chloride. And then we just need to multiply that by 1 over the volume, 1.50 liters. What we'll notice here, the grams of sodium chloride cancel, and we're left with moles per liter. So our units now are going to be moles over liters, which is equal to molarity. So our answer here, 20 divided by 58.44 divided by 1.5 is again 0.228 moles per liter, or molar.